welcome back to the second part of this series, which is C# design pattern. Today we will be talking about creational pattern, builder pattern, which is one type of creational pattern. So let's get started. So we have already seen this about the whole hierarchy of the design pattern, and one of them is creational pattern, and one of the creational pattern is the builder pattern. As I mentioned, we will be today talking about the builder pattern, which is one of the creational pattern. So what is builder pattern? The intent of builder pattern is to separate the construction of complex object from its representation, and by doing so the same construction process can create different representation. So you build different types of a particular product out of this design, which is the builder pattern. So builder pattern, UML diagrams and implementation. There is one director and there is a product. In between there is one builder which has the method or implementation to build parts, and there is a concrete builder which is a specific builder which build parts and get result out of it. So builder, this is a class which implements builder interface to create a complex product, which is this one. Concrete builder, this is a class which defines the parts of the complex object which are to be generated by builder pattern, which is this one. Product, this is the class which defines the parts of the complex object which are to be generated by the builder pattern. This is the final product. And the director, which is the one who gives the instruction. This is a class that is used to construct an object using the builder interface, which is this one. Builder pattern structure with practical scenario. So here we'll be talking about an insurance builder. So in insurance we have different types of insurance like auto insurance, car insurance that is, and homeowners insurance, life insurance. So we'll be concentrating on the auto or car insurance and the homeowner insurance. So if you see on the right hand side, we have a client which requests for an insurance. So it constructs insurance builder. Insurance builder builds packages and computes the installment amount, and the insurance is the object. The car insurance builder and the owner's insurance builder. Insurance builder does the same things, wherein it builds the package, compute installment, and has that object insurance. Insurance itself is the product which has add coverage and computes the cost. So same way, if you map this to the previous example which I just showed you, the director maps to a particular requester, that is a client. Builder is something which you build, that is insurance, and the concrete builder A, concrete builder B will be the different manifestations of that builder, and the product is the final outcome. So let's have a practical demo wherein I'll be talking about the types of insurance coverage. So we'll be concentrated on the auto insurance and home insurance, and we'll try to implement. So here I have an empty, I'm going to create an empty project. Probably I'll create a API, web API project for .NET Core, and I will load the particular application which will have the default code in. So let me do that. I've selected the folder and I'll go ahead and create this project. Don't want to configure HTTPS yet. So here we have the basic code setup ready. We'll just run this to confirm if everything is working fine. So here the basic setup looks to be fine. We'll go ahead and do the modification now. We'll do the basic cleanup. We'll delete this class. And we'll rename the controller to insurance controller. Insurance controller. Yes. And we'll go ahead and make the subsequent changes here. So we'll remove the unwanted code, which is this part, class later. Now we'll go ahead and add a insurance class here. Add insurance. insurance, which is our product. Now in the insurance class, we'll first start by adding two properties, which is private read-only list of string, and this will be our coverages, the insurance coverages, new list of string, and then we will add private read-only string, the type of insurance type, which is basically the auto or the car insurance and the homeowner insurance. We'll have a constructor here. The constructor will take the insurance type, and then we will do a add coverage, like void add coverage to add to the list. This is just for representation purpose, so we'll just do is add coverage, and then we will do a int compute cost public. This will be compute cost, int cost, the cost of the insurance, and this will just simply, for simple implementation purpose, we'll just return the cost of the insurance. So this is the basic insurance class. Now we'll go ahead and create the insurance builder. Public class insurance builder. Now this will be your having the property of the product, which is insurance. So public insurance and then we will have is our constructor. The constructor will take insurance type, and we'll go ahead and add the value of this to the new insurance type, and then we will have two methods, public void let's name it, let's keep it abstract because we will be overriding it. Build package. Different packages will be there for different insurance types, and then we will have a public abstract the compute installment amount. This again will be different for different types. And we missed here to mark this as abstract. So this is our insurance builder. Now we will have our concrete builders, which is our car insurance builder and the homeowner insurance builder. So let's do that. So this is concrete, so we will not add abstract, public class car insurance builder, and this will inherit from the insurance builder, and then it will have this constructor which will call the base constructor with car, and then we will have our overrides, public override void build package, and this will, for example, we'll take that object insurance which is coming from the base, insurance dot add coverage, and since it is a car insurance, what we can add is something like motorist coverage, something like that. There are different types of coverages which comes in auto insurance. And then we will have a public override int compute installment, and this we'll just do is a return of what we will have in our compute cost, and here we will pass something like 2000. So this is just an example. There will be a lot of logics which can be built in here. Similarly, we will have our homeowner insurance. So let me collapse this. So homeowner insurance builder, homeowner insurance builder. We'll just copy paste everything here. So that, yeah, home, and then here where will be having fire coverage, for example, and this will be around 4000. So this is how we have built the concrete builders, and we will now go ahead and do the director, which is our public class, which is client for us, as you saw in the PPT, and we will go ahead and do a private insurance builder, which will be nullable, and we will just use this property, right? We will use a method called construct as per the design, and let it have the return of int, because we are returning the cost. It will have the insurance builder parameter, and that will be assigned to our builder, and the builder will invoke build package, and it will return our builder dot compute installments amount. So this is the entire structure: the director, the builder, concrete builders, and then our product. Now we'll go ahead and do the API for consuming this. In the API, we will go ahead and correct this to be get car insurance amount, and similarly we will do for home insurance amount, get homeowner insurance amount. Now let's correct this one. Let me add this itself and then add as a route. So we will remove this one through this route. It is this one. Same way we will do this one. Now in this we will go ahead and create our client, where underscore client is equal to new. This client is our director, And what we are doing is we are going to call the car insurance amount car insurance to our builder, new car insurance builder, and this will return first construct, and we pass the car insurance builder object. Similarly, we'll do for our homeowner insurance. So here we will do homeowner insurance builder, homeowner insurance builder, and this will return the cost. So this is the basic crux of it. The construct pass the object of the builder, and it will do the work which is designed for it to do, that is to build a home insurance builder amount and the car insurance builder amount. Let's run this. So our application is up. We'll just go ahead and trigger the car insurance amount, try it out, and it comes as 2000. So our car insurance builder was returning 2000. That's what we see here. And similarly, we have the homeowner insurance. We'll try this out and execute, and we are getting 4000, which is our compute cost for our homeowner. So why to use builder pattern? We have a lot of parameter overload which happens in our programming, and it helps avoid long list of parameters in our constructor. That's one way of handling a better programming methods. And then we have immutability, can be used to build immutable objects, and also readability provides clear and readable object creation. Now when to use it? When we want to make the algorithm for creating a complex object independent of the parts that make up the object and how they are assembled. So it becomes a background implementation. And when you want to the construction process to allow different representation for an object that is constructed. So that's how we saw in the insurance example. Use case of builder pattern example is GUI libraries, creating complex UI components with various attributes, and we build those attributes. And then configuration management, building configuration with multiple options. You have different configurations for different environments. Document converters, constructing complex document representations, and also building a database query which is a little complex. You need to build all those different conditions into the query. Pros and cons of the builder pattern. It lets us vary a product presentations which can be done. It isolates code for construction and representation. It thus improves modularity of encapsulating the way a complex object is constructed and represented, and that's a single responsibility principle for you. It gives finer control over the construction process, and the downside is the complexity of our code base slightly increases. Now related patterns to builder pattern is abstract factory pattern. Both can be used to construct complex object, but our builder pattern constructs the complex object step by step, as you saw. Singleton, a builder can be implemented as singleton, so the base class which I composite pattern. Composites are often built by the builders. So that hope you like the video. If you like the video, please press thumbs up and like the video, and do subscribe to the channel. Have a nice day.